Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Monday Musings. There are a few universal things that the general public knows about paleontology. Dinosaurs. Apparently that's all paleontologists do, but hey. I remember that there are others out there, even if you are weird, invert, or plant paleontologists. Jurassic Park. I'm pretty sure that's like everyone's first foray into paleontology at this point. They know about the asteroid that took out the dinosaurs, because who doesn't love a good mass extinction? And then, of course, the supercontinent Pangea. Everyone knows about Pangea. What people don't realize is that Pangea is far from the only supercontinent to have ever existed. In fact, depending on who you ask, Pangea was the fifth major supercontinent to form. That's if you don't count the first continent to ever exist. Or Valbara, which was another proto-supercontinent thing from the Archean eon. Then you had Kennerland, which was the first true supercontinent, forming around 2.7 billion years ago. Then there was Nuna, or Columbia, which existed between 1.8 and 1.5 billion years ago during the Proterozoic eon, followed by Rodinia, which formed around 1.1 billion years ago, and Pannotia, about 600 million years ago. Pangea was named by Alfred Wegener, the geologist who came up with the concept of continental drift and the idea that continents change over time. It comes from the Greek pan, meaning all or whole, and Gaia, meaning earth. His proposal for the breakup was incorrect, as he thought Earth's centrifugal force just kind of ripped it apart. But he was correct that they moved it all, so he was onto something. It was this dude, Arthur Holmes, who proposed mantle convection as the mechanism for continental drift during the 1950s, which is the current hypothesis in use by the field. So, yay for the mantle. Now, Pangea began to come together during the Carboniferous period, as shown here, about 335 million years ago, but it didn't fully come together until the Permian period. Pangea stretched from pole to pole and was surrounded by a global ocean known as the Panthalassa. This configuration had a massive effect on the global weather and climate, as well as ocean currents, of which we will discuss next Monday. It was during the Permian period that the central Pangean mountains, which are shown right here, reached their peak height, pun intended, making them comparable to the Himalayas. Remnants of this amazing mountain range can be found in the eastern United States, the Appalachians, the Watkins Range of Greenland, not that you can see much of it, the Caledonian Highlands of Scotland, and the Atlas Mountains of northern Africa. Well, thanks for coming to today's lesson, and make sure you tune in tomorrow for some fun Pangean trivia. And I will fossilize you later.